Hello everyone, and welcome to this week's news and community spotlights. With the demand for Unreal Engine skills predicted to grow by 138% globally in the next decade, now is the perfect time to turn your dreams of becoming a game developer into a reality. Take the first steps towards an exhilarating new career journey with the Epic Games Game Design Professional Certificate, created in partnership with Coursera, a leading online learning platform that unlocks access to online courses, career credential programs, and degrees from world-class universities and companies. Designed for beginners and taught by industry experts with decades of combined experience as game developers, educators, and mentors, this comprehensive program will equip you with the knowledge and expertise needed to thrive in the games industry. The course is currently available in English and will be available in over 10 additional languages later this month. You can learn more about the course and register at unrealengine.com/feed or at the direct link listed below. Grab your party hat and break out the balloons. We're celebrating the Unreal Engine Marketplace's 10th birthday. To mark the occasion, we're bringing you a fantastic drop of freebies that range from stylized and photorealistic environments to time-saving gameplay templates. Let's check out this month's selection of free Unreal Engine Marketplace content. Modular Old Town by Cropcraft Studios is reminiscent of the medieval Mediterranean towns that tumbled down mountainsides in Italy and the Czech Republic. This modular asset pack will enable you to design an almost limitless variety of old world buildings. Create structures in a variety of shapes, from rectangles and squares to crescent and circular forms, and bring life to your scenes with street and marketplace props, decals, plants, cliffs, and rocks. Turn-based strategy RPG template by Phoenix Market is the perfect template if you're looking to get started in the genre. Packed with 205 blueprints, you'll find melee, range combat and magic units, passive and active abilities, equipment and spells, boss fights, and much more included here. Complete with comprehensive documentation to help you learn the ropes, the turn-based strategy RPG template is a fantastic jumping-off point for beginners. Customizable Interaction plugin by Vinipi Save is a great way to save yourself bags of time and effort. This modular and easy-to-understand interaction plugin is built in C++ and offers a highly customizable system that enables you to quickly develop a range of interactions in your game, from opening doors and picking up items to detecting the location of objects and more. Slavic Village by George Shocknev, set in dark and brooding pine forests, will transport you to the wildest depths of Eastern Europe. Comprising a comprehensive set of modular buildings, the pack lets you mix and match the pieces to design anything from foreboding, derelict ghost towns to vibrant and very much lived-in woodland settlements. It comes with 2 distinct example maps set in summer and winter, each complete with their own seasonal look and lighting. Low Poly Nature Lush and Diverse Environments by Vertex Rage Studio comes in with 800 low poly 3D models that span everything from weeping willows to furtive fungi, and a huge pack of nature assets that's enough to turn anyone's thumb green. You'll find a wealth of props inside, including trees, bushes, shrubs, flowers, and mushrooms, as well as geological features and terrain. Many of the assets are botanically accurate, and you can easily customize the colors to suit your needs. Remember to grab this month's content fast. It's only free until the end of September. Speaking of marketplaces, last year at GDC we announced Fab, a new content marketplace that is a successor to Unreal Engine Marketplace, Sketchfab, ArtStation Marketplace, and Quixel.com, built to serve all digital creators across industries. We're excited to share that Fab will launch in mid-October. Fab will be a one-stop destination where you can discover, buy, sell, and share assets. It will offer an 88-12 revenue share that puts creators first, enabling them to build real, sustainable businesses on Fab. To prepare for launch, we're opening the Fab publishing portal in 2 phases. As of September 17th, we invite Unreal Engine Marketplace creators to migrate their products to Fab using the Fab publishing portal. In early October, we'll invite new publishers to sign up and begin uploading their content, and we'll release a migration tool for the Sketchfab community to easily move their licensable content to Fab. ArtStation Marketplace will continue operating as it does today, with the goal of enabling creators to move their products to Fab in 2025. From Fab's launch until the end of 2024, Fab publishers will earn 100% revenue share on sales of Fab standard licensed products. Additionally, as part of a launch promotion with Adobe, users who publish a Fab licensed product or make a minimum purchase of $25 will be eligible to receive a free 6-month subscription for Adobe Substance Painter and Modeler. We'll share more information on this when Fab launches. Here's what you'll find on Fab at launch. Multi-engine, multi-platform support, offering content compatible with multiple game engines, including Unreal Engine and Unity, with more to come, and dozens of digital content creation tools, such as Blender, Maya, Cinema 4D, and Adobe Substance 3D. A wide variety of asset types with 3D models, 2D assets for game engines, environments, audio, tools, and plugins in multiple formats. Unreal Engine and UEFN integrations so creators can access Fab content without leaving the editor, making it easy to bring assets directly into their projects. Next generation real-time 3D viewer, enabling creators to inspect 3D assets and giving publishers the tools to easily present their work in real-time 3D. Powerful search and discovery tools so that creators can find the file formats or assets they're looking for quickly at the right price and under their preferred license. Multiple license types with tiered pricing for standard licenses, enabling sellers to make products available to purchase at different price points for personal or professional use. We'll keep adding advanced features, new content, and integrations with first and third-party content creation tools. If you're interested in learning more about Fab, the lead up to its full launch, and more, we've got you covered. Just check out the available article at unrealengine.com/feed. Interested in meeting some of your fellow developers? Here's a list of community meetups happening this month. Find one near you and enjoy. Whew, lots of news this week, but we certainly can't forget about our lovely community spotlights. First Love Memory by Maria Yui is a paintbrush-style variation of their other personal work, First Love 2.0. They utilized the incredible paintbrush post-process material by Anna Iancu, as well as a touch of Impressionism-inspired lighting design to recreate their favorite Makoto Shinkai anime style using 3D lighting. This stunning work is an incredible example of a very unique end result of the engine, as well as what is possible when combining clever plugin use, effective materials, and beautifully crafted assets. We highly recommend you go to their page on ArtStation to check it out further, as well as their other work. Kiara by Andrea Visson is an absolutely amazing character crafted using a combination of ZBrush, Marmoset Toolbag, Marvelous Designer, the Substance Suite, Maya, and Unreal Engine. They were absolutely masterful in creating a character that we can easily envision the story for just by a quick look, with tons of detail work put into every single aspect of the design, from patches to keychains to even little etches on the insanely cool prosthetic leg. There's tons of great shots as well as a bit of a breakdown available on their ArtStation, so go check it out if you're interested and give this artist some love. Tropical Island by Baikuni Abdillah is a beautiful environment that showcases a little hidden village untouched by all but time and nature. There's so much that we could go into for this particular project, from the impressive modularity to the stunning shots that had been set up. But truthfully, if you want to get the full effect, we actually recommend downloading the free playable demo that's available. This project features a realistic tropical jungle island environment with high-quality photoscan models and textures of trees, plants, debris, scalable rocks, buildings, tweakable materials, and a wind system, which are all available for purchase on the marketplace as well, if you find that you simply can't get enough of this gorgeous scene. We'll leave a link to their ArtStation for those who just want to appreciate the artistry, and a link to the demo and marketplace page for those who want a more in-depth gander. That's it for today's news and community spotlights. Thank you so much for watching, and we'll see you next time.
Hello,
everyone, and welcome back to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I am your host, Tina, and today with me, I have some of the wonderful, amazing team of Ironward behind the project that we're going to dig into today. There's a lot of really, really cool things that went behind the art of it, the building of the world, and some really interesting ways of using the new PCG tools to help adapt around the project and build along for it. So I very selfishly am super excited to dig into the weeds of it today, but before I get ahead of myself, let's go ahead and go through, have our guests introduce themselves, tell them a little bit about themselves, let us know who they are. H, let's go ahead and start with you. Why don't you tell us who you are, what you do, why are you here, all of the good things.
Thank you very much, Tina, and thank you for inviting us to this stream. My name is Hrvoje Hrvatik. I'm a game designer in Ironward, and so far I worked on all Ironward games, which is primarily our Red Solstice franchise. And now I'm working on Atre Dominus Wars, especially designing the systems for the game. Basically, that's it. We've been basically in the industry now since 2014. So we have some experience, and we transitioned to Unreal at 2017, which helped our processes and basically enabled us to do games much faster. We were on our own engine before, which was at some point outdated. And yeah, that's it. Thank you very much.
That's awesome. Yeah, thank you so much for being here. Next, we have Brant. Why don't you tell us a little bit about yourself as well?
Hello, my name is Brant Borges. I am the lead programmer on Dominance. I have been using Unreal. I think I just started right before 4.23 released. And I've been professionally working since sometime in 2020, I believe. About all.
Amazing. I love that. So relatively not new, because 4.23 wasn't super new. You've been in the weeds for a little bit for sure, but newer, which is exciting. You've done some crazy things for only being in the engine for that amount of time. All right, and then last but certainly not least, we have Ivor. Tell us a little bit about yourself as well.
Hi Tina, hi all. So my name is Ivor. I'm the lead artist in Ironward, but mostly doing the environment art myself. And yeah, I've been in industry more than 10 years in gaming, and even more with 3D and stuff. And I also come from Croatia, as the studio comes from Croatia. So, and with that, yeah, I'm also using Unreal. I think it was 2.15 or 16. So, you know, it's been a while, and yeah, I love it. I also come from other engines before, and especially using a really old engine to jump into Unreal, for me, that was like, wow, Christmas back then. And yeah, now Unreal 5 is here, and I feel quite the same and excited with the new stuff we'll also mention today.
Yeah. I am really excited to dig further into it and see how y'all have utilized some of the newer tools. It seems like y'all really just went for it as soon as they came out. You adapted them, you used them very well. And I'm really excited to kind of look more into that process. So first, H, I'll hand it back off over to you. I know you were going to give us a little bit of kind of an overview of what the project itself is that we're going to talk about today.
Yeah, thank you, Tina. So today we will talk about Atre Dominus Wars, and it is a 4X fantasy game where your primary goal is to become a god and rule everybody. So it has elements and is inspired by elements from Heroes of Might and Magic, and the setting and story is inspired by Tolkien, Lord of the Rings. So yeah, you're kind of playing a Sauron guy who wants to rule the world. That's the short story.
Love it. So we're the bad guys. That's what I'm hearing.
That weird guy, yeah.
Yes. Awesome. Well, for anyone who's interested in seeing more, we actually have a trailer for the game that we'll go ahead and play now.
Another elder returns. Will you venture bravely into the unknown? Exploring an ever-changing world in search of power? Will you bring blessings upon others? Or bring destruction? Expand your dominion over the realms. Master the magic of the four worlds. Study ancient script and forge artifacts of untold power. Raise your armies and transform them through arcane knowledge. Crush your enemies and their cities. Unleash the might of your legions upon the world. Annihilate all who oppose you and ascend as the Elder God.
Oh my gosh, it is just so cool. Can we play it again? We'll go back to the top and play it one more time, right? I'll do that on my own time, I guess. We'll get into it. I'm sorry, everybody. I'm sorry. But yeah, that was incredible. I love the style of the world that you all have built. It really does fit right into that kind of nostalgic, like some of the older games that we would play with all the bright colors, the style of it, the way that it plays, but it also feels very new, very fresh. It has a lot of really interesting spins on it. So Ivor, I'll hand it back over to you because you were going to talk a little bit more about the process of making this world, right?
Yeah, I mean, mostly from the art perspective and how we get to the whole world, how it now looks. But yeah, before I start, I just want to get into a little bit the whole idea and how we actually start imagining the whole world, because at the beginning we had the requirement that we want to create the procedural world, and we know that that world we have four different environments, let's call them planes, and each plane will have its own culture and all background and everything about that that was created. And it was really helpful because in early stages we already have a really deep lore, and we had like 90 pages of the book, which was the whole history of the Atre dominance and with the stories and stuff. So we start pretty quickly using some inspirations and stuff what we can use, but having all that, at the beginning, the biggest issue was, well, procedural. Everything needs to be done by code. Nothing can be hand-painted and everything. So at the start, to create the world, and I can show that in the little process we did, and it's maybe a straightforward, but it kind of shows the process of how we get into the whole world. So the first is always the basics. Let's just start with some few easy textures, easy colors, easy things to understand, to create the whole thing out of it, because you have to start something. And then once the basic idea of the planes came around, we started playing with the idea how to connect the world together, how to have different planes together, how to have, and of course everything here was just static and trying to get things done quickly and iterate over the process. Now, one thing about the dominance, the Atre dominance war, was that the whole four planes that were merging into the world, from the lore, the whole existence was kind of merged together with some catastrophic magical event into one world. So we use that. Yeah, so that's why we use that. Also something that we integrated into the whole world creation. And from start, it was really important to have those rifts. So clear, how it's called, the boundaries of each plane. And with that, just a simple thing to iterate. Now, this is one of, I think it was maybe 50th iteration, but we start trying this, trying that, different styles, different everything. And here was the first time we kind of say, okay, this is going somewhere. We like this, so we can step further from there. So while the programmers were starting to do all their magic with, how systems should work and how things should generate from code, we were still playing with the whole idea of the world. So I can actually have to mention here, this process was really easy using the Quixel suit with the mixer, just banging textures together to get some landscapes, some snippets of landscapes, and getting good ideas, and also with usage of how it's called, oh man, to get the height maps and procedurally get generated terrains out of the textures. So that's a nice thing in Unreal, that it allows to create actually geometry now in 5 much faster and without materials, and it gets a really good first shots of some of the worlds we were trying to get. And now here, if you can see, so those two was quite similar, but this is one world. At the beginning, it looked really, really different from where we come to the end. So this is the ice world, if you saw. It is the wooder world. And the idea of the wood world was that it was drained out of magic and, quite destroyed and stuff. But once we start connecting everything together, things just didn't work as we, as we were imagining at the first. So we changed some of the stuff in the process. And that was some initial test we did for the whole terrain. I mean, these are just snippets of the whole process, but the idea was there.
You mean it wasn't as fast as you just described it?
Yeah, it would be nice. But yeah, this, I think it took maybe a month or month and a half, just trying all the crazy ideas and try stuff. For example, this was also bot texture, so we were also experimenting to see how we can do world with 8K textures and big ones to get maybe better resolution, to get them unique looking and everything. But also having close-ups here, we soon ditch also those ideas because it just didn't bring the quality we were looking for. And then again, a lot of tests were done, also trying to get things procedurally generated from the material itself. All the foliage and everything was generated in, but also didn't give us the desired results we want. And while we were doing all these processes, one thing that was kind of always back in my head was to try to get that feel of retro games, to get back where, all the love I had for gaming back then, and I had too much time on my hand to play them. Yeah, and that's why the biggest decisions we did was that our main terrain will be flat. So we will not have any heights, any, procedurally generated things like we are having here, or that we are not going to have nothing like these things, and that will combine the actual models of mountains, lakes, and anything if you want to have any heights. But the only height actually that at the moment we have on the terrain is the reefs itself. Everything else was flat. And with that, we start building our shaders and start creating the final look of the world, which I will show a bit later. But now I'll just
keeping us in suspense, I see.
Yeah, of course. So that was pretty much the base process of the world. Another thing that was really important, and it took also a lot of time, was choosing the right colors for the whole world and choosing the color palettes and stuff. Now that process was also helpful because we had the lore book, which had a lot of descriptions about different different worlds, different cultures and stuff. So, for example, we have the the Had culture, which is a desert cultures, and they are, like strong and living underground. But that was kind of easy to understand. Okay, deserts are usually brown, yellowish, so that was kind of the first color we kind of went with. Then another thing, we have the men world. They are more like humans, but they have, like, let's say, their dark another side and dark secret. Let's keep it for now like that. And but we chose to let's go with like a normal world, and with those we kind of, it was easier to start with just two colors, trying to get them right, trying to understand what's going to happen with those. And then up to there we start doing next the wood, which first of all was kind of, here if you look here, it was kind of bland. It was gray, and it has a lot, again, browns and greens, and it just didn't feel right to rest of the colors. So we went completely in the opposite direction to get it more snowy and more vibrant than it was initially created. And the last thing, the wood, and then are that not the wood, the Aerolek, sorry. Aerolek faction was the faction that was living in a magical forest. So for them, we didn't really know what color we should use and how we should approach that. Because we tried a lot of other things like cyan colors, like also getting too saturated greens, and a lot of colors to have like a rainbow effect or anything, but nothing really strike right. And with a lot of experimentation, we ended up using purple as that vibrant and saturated purple, which really give kind of unique look to their world, and with highlights of some cyan and stuff with it, it really pop up the whole thing. So yeah, that's, let's say, in short, the process of how we created the process of art. And the biggest thing when we start creating all this was also systematically adding this to our real map and final product. And that's also something Brent was doing from another side. And before I leave him to explain how the world was created, we also started to experiment with PCG and stuff to how we will connect all the elements to the world and how everything will spawn and how everything will work together. But for now, I would like to leave my word to Brent, and he can start explaining first how we get to do where we get with the world, with the procedural thing, and I'll jump in a bit later.
Very nice, very nice. Thank you so much for walking us through that. I love seeing the different phases of the beginning process there of experimenting and seeing what worked and didn't. I love getting that kind of look behind the curtain. Cool that you kept that. Honestly, I know a lot of people just kind of, if it didn't work,
well,
they get rid of it. But
that's just a few of the things that left. Unfortunately, most of the stuff did get deleted in the process. But yeah, sometimes I really like to keep things because you never know. If you go back like 2 months, 3 months after and look at your art, and then you're like, maybe that was a good idea, but I just ditched it too early. So it's always good to have, some follow-up and that. And another, of course, and when you look at the end product and when you have all the iterations, then you can see where you were and where you're going. So it's always good to have something like that.
yeah, great tip. All right, Brent, I leave us in your capable hands.
So, you've all seen what Ivor was working on first, and I was given the task of doing procedural worlds using that art set, which, I gotta be honest, is a very daunting task because I have never actually done world generation code before. My general expertise is like UI and such. So
Nothing quite like getting thrown into the deep end, right?
right, definitely. So to start off, I gotta be frank, I had no idea what Voronoi even was. And Hroye comes and starts giving me all this Voronoi stuff. He's like, I want Voronoi regions and whatnot, because they look much more realistic and such. And I'm going, dude, those are shaders. Because the only examples of Voronoi that I've seen up to this point are the neat little Voronoi shaders and such that everybody's done. I'm like, how do people do this into like regions and stuff? That doesn't make any sense. It's a shader. You can't. So of course, me being the naive little programmer I am, I start learning shader code. And I'm literally creating this world visually in a single shader. As anybody who is familiar with shader code can probably already know, I think it ran at like 15 frames per second. It was terrible. So
it's okay. It's a picture show.
We start caching things. We get to a point where it's kind of okay, but it's very clear that when we get to a much bigger map, this is not going to work out in the end. So I start trying to figure out, how can I transfer what I have managed to draw in shaders into actual geometry. And it was kind of brutal at first, but we ended up on landscape for now because it just works and it's relatively performant as far as geometry goes. So we worked with it. How this all worked out is that we have a grid set up. If I can go back to the event graph here we go. So these two little lines of blueprint script here are basically what generates all of our visuals in the world. To not complicate it too much, we'll start with basically the server representation, listen server technically. Because I did this because we actually need all of this code to run on even like a dedicated server. And this stuff here on this bottom graph is all visual, meaning that most of this stuff will not work in a dedicated server. So we started there. We found a nice scalable solution that I don't remember exactly what the math is offhand. The world starts by picking two variables. We start off with a randomized seed, of course, and we need a player count size. Player count is what drives the grid size, where we decide what we want to pick where. This is because every player needs to have, I don't remember what our current requirements are. If memory serves, we need 7 total points per player at bare minimum. That is, we have 1 throne, which is like your primary gameplay actor, and then we have 6 villages that are spawned per player. That subject to change. Don't quote me on that, please.
No, it's too late.
Work in progress. But so we needed a grid that is square that we could work with on that, because landscape is very square, so we need a square grid. Like I said, don't remember the math offhand, but it was basically player count times 7, or the requirement list, so 7, times some number that ends up squaring off. Like, for example, 2 players, I do believe, ends up at a 5x5 grid or something like that. If you have like 8 players, I want to say offhand it might be something closer to 7x7 or 9x9. I can't remember exactly. So anyway, having our player count and our seed, we generate the grid. That is all thrown into an array. We take the array, we randomize the entire thing, and then we just simply throw out whatever gameplay actors need. For example, we can randomize it all, pick a random array entry for a throne, give it to that throne, and then we also need 2 joining regions for specific 2 starting villages, and then we do that for every possible player. And then all the rest of the points are just kind of randomly given out to any villages that are left over, because we only specified that we needed 1 throne, 2 villages, but we still need to spawn 4 of more villages and random points for each player. Those are kind of preferred towards each player, but it can be very random. You can get a very brutal roll right now. That kind of gives you a blank canvas to play on. As Ivor mentioned, our maps are entirely flat, so technically speaking, you can actually completely ditch the entire landscape and still play the game, because everything is relatively, actually, you still need the geometry there because the pawn will fall through, but other than that, it's relatively flat. So now that we have that, we have to generate some visuals. This was my first foray into Voronoi as far as non-shaders go. I started actually writing out a Voronoi system myself.
Oh my god.
That was exactly my original thoughts. It didn't work out because I think I was like 2 days into it, and I accidentally stumbled on the actual library that Unreal already has for Voronoi, and I started using it because, yeah.
Less work for you, you know.
I could probably manage it, no problem, but it's one of those things that it's a bit of a brain twister in the end, so it gets complicated. Those of you that aren't familiar with Voronoi in general, I can actually just bring up a little diagram here. Voronoi, in its simplicity, this is Euclidean Voronoi, basically says these little black dots are sites. These are the primary point at which you're going to expand your Voronoi from. The graph here will expand until it is too close to another point, meaning, like, for example, let's take this little pink dot here. You'll notice that every line between these dots is perfectly the distance between the 2 points. So you have a perfect distance here and a perfect distance here. It's the same for all of them. Because, like in shaders, if I was to grab this pixel right here in shaders, it's basically a distance check. So, like, we have a single pixel and we need to distance check it to all of the points, which is why it's so expensive and why I was having so many problems caching it. So we know that it belongs to this point. So we can generally say that all the points that are closest to this, that are not closer to any other point, belong to this pink area. That is the general idea of Voronoi. Very simple, but it also gets incredibly complex because when you generate out Voronoi data, you need a lot of things. First of all, you need the points here, like you would need vertices to create actual geometry out of. So you need a vertex here, 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 and here, of course. And on top of all of this, you have to know all of your neighbors. So this point has to have relative data to this area, this area, this area, and this area. And it just kind of gets into a nice little complex problem that I'm really happy that library solved. So, as you can probably notice from this graph, this is kind of ugly. You look at this and you're like, that does not look like regions. Why would anybody use that for region generation? It's so straight. And it's true. I can actually show this if I go where? Here. If I unhook this, this actually gets a little bit more variation in our lines. So if I actually unhook this and play, you will see exactly what I was pointing out. That, let me ditch my fog of war here. You will see that all of our regions are very straight. And it's terrible. But that is the basic Voronoi. It is very simple. So this is basically what I started with. I can actually show this a little bit better here. Oops. I always forget to hide the indicators.
Same, honestly. I think we can all relate.
PCG's taking a minute.
That's fair, as it does.
But yeah, well,
Much
that's
better than we
doing
did
its
in
thing.
the beginning.
Oh, there we go. Now I can close that. So this ends up leading to a lot of problems. For example, you can already see one right here. This cluster here should not be here. We get bad, it's not smooth enough, so it kind of projects very badly off to the side where it's, Ivor can probably go through this a little bit more when he's doing PCG stuff. But you end up with this basically, and it's just so straight. I can't come up with a better word. It's just terrible.
Geometric, boring.
Yeah.
I get you.
This doesn't look like a region. It doesn't look like something that like crashed together from multiple planes of existence and just turned into a giant craziness of regions.
Yeah.
So we had to take the Voronoi that we were given, and this function goes through and it will create actually I kind of want to showcase that really quick because I didn't cover that. You'll actually see that this does not keep hitting ensures. There we go. This should not, whoops, create. Yeah. So you'll see that there's not a lot of points here on these splines that are surrounding the areas, like very far. And I can showcase this because this will be the same with the same seed. So if I quit playing and hook this back up, we can go back in and see that same region, which was here. Oops. Whoa, way too far. I have no idea where I went.
Outer space. You're showing your new space map, right? That's the new, that's the...
We'll go with that. We'll restart that. Give PCG a moment to do its thing.
Is interesting. I do love this because it's doing a great job of showing that even just one extra little node can make a huge difference in the overall outcome.
But yeah, basically what that does is we shift around a couple of these points. Like this point was originally, I do believe, straight through here. And what happens is we actually project a lot of these points with Perlin noise. Those of you who are not, I can cover that too. I had a thing on that. Those of you who are not familiar with Perlin noise, it's actually very simple. This is generated image of Perlin noise as an example. Very fuzzy, but doesn't need to be clear because sometimes Perlin functions aren't. The 2D version of Perlin noise would be like saying, let's say this was a generated grid of like 10 by 10. So you have 10 down, 10 across. And we got 5.5, or sorry, 5,5. So that'd be directly center. That would give us whatever number is right here. The number comes from the shade of color that this is. Perlin in itself is not actually a graphical thing as much as we give it coordinates, either 1D, 2D, or 3D, and we get back a simple scalar that is either -1 to +1. What that does is allows me to take this point here, and this point was originally at the start of this, and I took its actual world location as a 2D point, fed it to Perlin, and that gave me either a -1 to +1 value, which I then used to shift it in relation to its original side points, meaning that this point was originally here. And I do believe, yeah, you'll notice all of these are in line. So all these points here shifted this way. But this one, of course, shifted a little bit further because its value ended up a little higher than the rest. I don't know if I have any better examples of that here. Here's a good one. This one actually shifted the other direction. Oops. These two ended up getting pushed this way. This one got a different Perlin value and went the other way. It's really neat doing this because you can actually see where these lines originally were. There's a very straight line right here. And using that, it allowed me to just basically randomize the direction that these splines are going. That was actually fun to do originally because after I had generated these areas and given them all extra geometry as opposed to the normal Voronoi geometry, I had to go through and link all of the vectors together so that I could move them together. What I mean by that is I needed to be sure that, like, there's actually, I don't know if you can see it if I get close enough. There's actually two splines here. Because, or I can't really see it. Each region has its own spline. So does each region cluster, which I'll cover in a second. But I needed to be able to move both splines together to the same exact spot. And I didn't want to have to deal with any complexities with that. So I simply linked the vectors, moved them at the same time. Nope, I'm gonna go here. The purple outlines you'll see are regions, clusters, specifically. What I mean by that is that instead of a specific region, it is a cluster of the same region. You can see it very easily with maybe the Budar area here. Yeah, that works. There are actually two gameplay actors here, both of these. But you'll notice there's no seam between them. And this was fun to manage at first. because I had to write a predicate function that would run through all of the regions and collect them into their own set of clusters by themselves. So these are all done based on the region visual style. What that means is we actually have a data asset that is populated with all the possible like PCGs and the visual data that we would need to actually create this region visually. And a similar region visual style means that these two regions are supposed to be similar, even though this region here could actually have a very different PCG graph than this region here. But because their style data assets are identical, they merge into the same group. So moving on, you'll actually notice if no, I don't want another client. I want to detach. The purple line is the cluster area around here. And we also have separate splines between each region. Right here. These splines, and you'll actually notice if I click on these, I get all of the PCG stuff that we generated highlighted because it's in the same actor. These splines here are what determines the area that this graph, this PCG graph, can actually run in. We took this idea. I don't even remember where we saw it from. I want to say it was one of the YouTubers, Aziel Arts, maybe. I'm not totally sure. Because we were watching them literally just move around splines, and forests would just swath out as they moved the spline points. It was really awesome. And we were thinking, dude, why don't we just wrap the region in a spline and let the PCG graph go?
Let it wild.
And that's exactly what we did. You can actually see if I zoom out here, that one spline in the interior of this here kind of encompasses all the PCG stuff.
Love that.
So back into our blueprint. Whoops. I actually want to go here.
It is blue, but
so basically, quick rundown. This area runs immediately as the player has the initial data, the seed and the player count, because we want to generate all this data specifically on the client because it's a ton of data. We don't actually want to network all of that. So, and it literally all can be generated on the client, ready to be used. So what we do is this event gets ran. Okay, to back up a little bit, the player joins, they get a player controller. Their controller initially waits for the game state to be ready, I do believe. I can't remember. There's a thing. It either waits for the game state or the game state is ready. Either way. Once that happens, it does a handshake with the game state, which the controller then asks the server for the actual world generation data, the seed and the player count. The server sends that back. Then all of this data generates. We have all of our basic data. This is the landscape resizing. These are our Voronoi sites. These sites are actually the same as these, like I said, these little black dots here are all sites, as they are called in Voronoi code anyway. So we have our region point actors, which we create on the client, name stable, so that they can be referenced in RPCs and also replicate. Then we generate our initial Voronoi data. This is basically running those sites through the Voronoi library, letting it do its thing. Then we kind of I can't show it easy because that's all one node, but basically, like when we have a region, I actually probably should have unhooked that because it'll be much easier to see. I've got to fix those shares. So like when we have the basic region here, nope, stop clicking on gameplay actors. Oh, probably help if I was actually out. I don't need to hide that. So when we have the basic Voronoi data, what that gives us back is basically, I do believe, like this point here, this little point here, and then we'd get like this point here. And that's kind of a problem because we have nothing in between to move. We need to kind of swerve our splines a little bit because otherwise it just looks straight. Like even here where we have extra points, it still looks straight because we haven't swerved anything. So we actually, that function also, on top of getting its basic Voronoi data, goes through each spline and populates some extra points in between all of these so that we have extra data to work with. This function, as you've seen what it does many times already, basically offsets all of our spline points, makes them a little more wavy, so they're much less rigid and straight.
Can I add? Sorry, I can
Sure.
add one thing for this node because at here it looks like really simple, just it's one node connected and everything work together, but it just reminded me when we were doing that and how much you and me were going back and forward, and I was like, no, make it more randomized. It was still straight because it's usually that between artists and programmers, because programmers, they connected to things, look, it works, it's good, ship it, and then we artists come, it's like, no, let's complicate this. Can be that simple. So yeah, it sounds easy, but that thing also took some iterations to get it right.
Yes, the constant back and forth between art and programming. Yeah.
and I will say, Ivor is correct. It is just one tiny little node, but I gotta show this. Like, it is one tiny little node, and I have something stuck on my screen. Why are you doing this to me? Go away. There we go. It is one tiny little node, but it runs a little bit of code.
A lot of function, yeah.
It goes places. So then we need one more thing. This function. No, I did actually move that to C++. This function creates some geometry around all of our regions. We didn't actually originally have this because we were only worried about graphics, and like if I unhook this, you probably won't see anything. I have no idea what will happen if I unhook this. Honestly, I've never tested it. I don't want to crash, so just gonna leave it there. But can I actually showcase this? Do I have the ability to? I don't remember where that was. I can maybe look at it later, but what this does is, unhooking this again, it creates a region. Actually, no, sorry. Actually, I don't want to unhook that because I need it. It creates a dynamic mesh on every region. And we did this because we needed you can kind of see these if I do this and I zoom out a little. Can I actually stay zoomed out and still, or is that going to, oh, nice, awesome, perfect. So I don't know how well you can see it right now, but this blue line right here is created from the same geometry. It is not actually the same box, but it is created from the identical geometry. And you'll notice it goes perfectly along this spline here. So what these dynamic meshes are is we put these in because we had no idea how to figure out how an actor was in the region. And I started running it through my head. I started actually like Googling and trying to learn how do you detect if a point is either, like, there are a couple different ways that you can check if a point is within a concave or a convex hole, but checking both at the same time gets exceptionally complex. So, and even trying to write out the code for it, you very quickly start realizing there's a ton of points in this game, and that is a function that is going to be used a lot. Like, our Fog of War is one good example. Fog of War shows if your gameplay actors are within a region, like moving an avatar from one region to the next. And there's a ton of points, and doing all of that math for every gameplay actor for anything that might need it just came off as not scalable at all. So what we did is literally just use the geometry we already have that we're already using to create splines and stuff to throw a dynamic mesh component on the actors or on the region actor itself, and it creates a I want to say box, but that's actually not technically correct because a box is 8 points, but you get the point. It puts a boxy mesh around the region that allows us to line trace from the sky to hit the box. So, if we have an actor at like maybe this location here, we can line trace from like way up here and just go straight down, and we hit a region box, and we know, okay, well, that actor's in that region. Easy. And it was a lot easier to simply use the geometry we already have to create these boxes and do simple line traces than it was to figure out some crazy complex method of doing the whole concave convex figure, because it was not going to work. So that is what this very last node here does. These all run, like I said, client side. Once all of this is done, the internal code that originally calls this is all blocking. You might notice it's not, none of this is async. It's very quick to run. This then calls back to the server to tell the server, okay, this client has all of its basic gameplay necessities set up. So we set an enum on our player controller. I can actually show that. The class is actually really small. We did this because it was very quick to do at the time. Yeah, here we go. It's a very simple actor class. We have the basic actor class that most of our gameplay inherits from, except for our pawns, of course, which they check the local player controller to see if its world generation is finished. This is all server-based. If the player controller has not finished generating, we don't want any of the gameplay actors to be sent to the client whatsoever. So we use this as a stopgap to keep the server from sending the client any data until that client is entirely ready. And ending this function here does that for us. Later, this gets ran. On the server, it gets ran immediately, basically right after all this happens. But on a client, of course, we have to wait for a little bit of data, not much, but a lot of stuff gets replicated. So we don't have the ability to pick and choose. I thought about doing this through an RPC, basically, and I may still do that. I'm not totally sure, but this is working for the moment, so I'm leaving it. But basically, the region visual styles that I mentioned before, oops, just need to go here. The styles that determine that this region here is the same as this region here have to be replicated to the client. And that needs to be ready before we can start setting up any of the real visuals. So what ends up happening is we start this function. We go through this is common loading screen. We pulled this from Lyra. And it literally we create a loading screen process task. And later, once all of this is done, it gets unregistered and nulled out. So while all this is going, we have a loading screen up. This is a very hacky wait right now because I still want to do the RPC version, but needed testing. So we have a 2-second delay waiting for the client to make sure that it gets all of its stuff. This runs, and every time client sends new data, like for example, if we get half our actors here and then half a second goes by and then we get the other half of the actors, we're like, wait, no, we just want to wait another 2 seconds to make sure we're not going to get another set.
Listen, if it works, that's all that matters, right?
This will clear out some of our render targets.
Later.
Yeah.
Yeah. So first we want to clear out our render targets because we don't know if this data has been ran yet. If something happens and this 2-second stopgap, like everything here, I want to point out, just to back up a second, everything on this line can be reran. If something bad happens in the middle of the game, I don't know what exactly, but data changes, whatever, this whole script can be reran. Throws up a new loading screen and regenerates the whole world over again. Visually, at least, this stuff stays. So we have to clear our render targets out. These may not have the same data, and we don't want to worry about like having artifacts remaining, so just clear it all out. These are some material parameter collections. I do believe they're mostly for the landscape sizing stuff that our tech artist uses. Right. We create some new render targets. We did this like this because some of you might be more familiar with creating render targets in your content browser here. We did this like this, and we actually generate this at runtime to create render targets here for a very specific reason. We have an issue in Red Solstice 2 where when we're testing in the play and editor, our render targets are in our content browser, which means it's the same render target. And that ends up leading to having very fun experiences in our play and editor when we have the same technical process accessing the render target data. So we have server and client here both fighting for the render target data at the same time.
Oh, no.
And you get crazy flickering, and it is so terrible. So we created a render targets runtime this time. So that is what this node does. This is actually C++. Yeah, this is actually very simple. We give this function our origin render target that we created. Mostly, I do believe it needs size, right? Yeah. So all this does is we need the size of the render target here to generate a ton of triangle data. Basically, our regions here get cut up into like, where's a smaller region? Here we go. That is Can I do that without the red? Maybe. There we go. So our smaller region over here would be cut up into a few different triangles. Like, for example, this is done based on the same splines. And what ends up happening, actually, it's this is all done by our cluster data, not region data, cluster data. But we do this per cluster or per region for the cluster. So basically, this area here gets triangulated. You know, we basically take the vertices, we go create a triangle here, create a triangle here, another one here, another one here, and then, you know, fill in the little areas here. And it just generates a ton of triangles that we can use, which we use to literally draw on render targets with. The sizing input is to give our render targets the ability to project the correct locations from our world location data, so that we have the correct triangle sizes for a render target, because the render target is what ends up running, getting used in the landscape material to actually draw out the different masks for the zones here. Like, you'll notice if I don't know if I can actually zoom in close enough to the rift with it on. I think it's all pure black, but it might show some of the sides. Yeah, you'll see like the sides here. I don't know if I can see a good one. There we go. You can see like the rocky texture here for the one, and then over here we still have the like desert texture, because the seam for that is right in the middle of the rift. So it just kind of projects this area here, this area here. And that is what the triangle data is used for. Basically, literally just, it's a pre-created array of triangle data that we can draw to render targets, because originally we were planning on using a lot more, and we kind of just start transitioning away from that a little bit. We found a couple of different ideas for other things, like actually the blue thing I was pointing out earlier is a good example. Oops, back out. These areas here, we were doing them on render targets at first, and it didn't really work out that well. So we decided to do them as actual geometry in the end, because it's much faster rendering wise, and it was much easier for us too. Then we basically just say, hey, you know, fog of war triangles are done. Please run a fog of war update. Here is actually where we were generating those splines that I've been showing off already. If you've been paying attention, I've been calling things regions and clusters. Mm-hmm. This generates the clusters, this generates your regions. So, you know, if not actually going to unhook those. Do these actually, I think these actually have, yeah, these are all blueprint graphs. I do not advise doing this at home. This is a lot of looping and blueprint. But yeah, this is actually a good example of what I meant by the predicates. Basically what this does is I have a function that takes in a predicate function, which I need to not be playing at the moment, which is so wonderful. Wow. I have to clean that up.
Hey, a little bit of spaghetti never hurt anyone.
Ignoring all the craziness here, basically it ends up at this, which is, you know, if your region point has its region data available and its region visual style is ready, and those have the same ID, then it belongs to the same cluster. Because the only thing we care about is whether or not the visual styles are the same. So that gets ran, and we get a structure of data that has a bunch of cluster data. Every cluster data is, of course, the set of regions and its complex data and stuff that we have for every region in the cluster. This we use to pull out the surrounding points for a region. Like, whoops, gotta fix those ensures.
That's a later problem.
That is a later problem. There we go. So, ditch my indicators and my fog of war. So basically what that function does is it has to go through and say, okay, we have, well, we can use this region. We have what? There are 2 areas here, actually. Oh, that's weird. Giant area. We have 2 areas here, and normally their area data would have area points going between the 2 zones. What we want to do is get all the points that don't go, but do surround the entire area. That way we can throw that spline around the entire area. That is basically what this function does. Gives us back an array of edge lines, which is basically 2 vectors. Gives us a literal line around the edge, hence the name. So then we basically use that data to, I don't remember what this is actually. Right. We actually have another render target for our rifts. I do believe this is actually being used to do the world position offset. If you actually look at our rift geometry, we actually have no, like, the landscape itself is not being altered one bit. It's all visual. It's shader work and world position offset, which is basically what this is doing. It's drawing our rifts to a render target that we can use to do that. Then it's also gathering all of our points so that when we are done, we can create a spline actor and give it all of our spline points. And I don't remember what this temp pack is. Right, I wanted to move this to C++, this whole thing, but this is a blueprint pure actor. I don't have a C++ base for this, so I can't actually move it there. But it works for now. And I don't remember this segment down here. Right, this is taking this region, for example, this area here, all of this, all of both of these regions, and it is drawing those regions. Actually, it's drawing everything, but in the thought process of simplifying it, it's drawing those 2 regions to the render target with the color that we're using to mask off this. The word's right there.
It always
like
escapes.
zone. So that is basically what this does. We use all of this cluster data to draw a ton of triangles to another render target, which then is used. That is like this actual draw right here is actually what draws the colors that end up masking off this zone here against, like, you know, this zone here. Then we do a very similar thing for each region. Same predicate, but I don't remember actually. Wait, why is this? Right. this does basically the same thing. And then we end up with this. This is where we actually tell each region which PCG graph to run. What we do is for every region, we get all of its border spline points. Then we tell that region to set up its area spline based on those points. This is a little plan editor fix thing. It's actually not that complicated. It's just basically, if you're a plan editor, if the world settings have a don't run PCG, then don't run PCG. But otherwise, if you're not plan editor, always run the PCG. A little testing so that we can quickly test certain things if we don't want to wait on PCG to run every time. Then we pick our PCG graph by seed. This is, I didn't even know why I did this originally. I did this because I had it planned out, but we still only actually use one graph right now per area. So this is totally pointless. But what it does is the seed is basically based off of its entry. And what we do is we use that array location to randomize based on how many PCG entries each area has. This comes straight out of our region visual style data. I don't know.
Yeah, but you said this part of the code is useless so far, but this is something that's going to start be important soon, really big time. Yep. Because this thing will allow that each region, so for example, if you see the green forest, that the forest won't always be the one PCG graph, but by each cell you can create different kind of forest environments. So once you get everything inside, you will have like a really rich world, and it won't be just forest all over the place, but it will be the same theme.
So I'm gonna open up a couple of these because it's neat. Because these are the region visual styles I was talking about before. That I'm literally basically just comparing whether or not these are the same cluster ID here in these styles. And what we end up doing is that each region gets their own style. So for example, Menar here. You'll notice if I go through these really quick, the culture RT color, that's what actually was being used as a color to be drawn to the render target. So, Menar, we have a pure blue, Hadar, we have pure green, Erlek is pure alpha. And then we have Budar, which is pure red. We can probably end up doing even more if we get to that point, but we started with 4, so we just kept it simple. But this data is everything we need to define an area. So, for example, right now, these PCG entries are the same things that I was pulling here. There's only one, so of course this randomization is utterly pointless. Did I go to the wrong one? I went to the wrong one. Yes, I did. But if there were more entries here, that would randomize out for, maybe we want, like, I'm not an artist. Please don't shoot anybody if this goes into a thing, because I don't make these decisions. But if we wanted like a Menar area that was like pine trees instead of the normal trees, or like a Menar area that was like pure birch trees, or whatever other artistic expression you want to go with, trees, rocks, anything that kind of signifies that this area is a little bit different than this area, even though they're from the same planet, plane, whatever, for lack of a better term. So, you can go through this whole green area here, and this area here might be wildly different than this area here, but still close enough in visual representation that you can still make shift difference between the desert areas. But it gives a lot of potential variety to the kind of regions you can create. And, basically everything that gets differentiated by its region type gets thrown into one of these data assets, as, like we have road meshes here, whereas Erlich might have very different road styles, So that's basically what that does. And it sends us this back to use. We basically check if it's valid, and we tell our region to run the PCG graph. I want to point out that as a programmer, I absolutely love PCG for this region.
That's good to hear. This is good to hear.
We originally started on Dominance as like a side project. Atre Dominance Wars. And it was a bit of a daunting thing. And, everything has to be procedural. Everything down to literally every blade of grass has to be procedural.
Right.
And as a programmer who is, relatively fresh in the industry still, I'm like, dude, you could put 2-3 programmers on this for like 2-3 months, and we're not going to have even close to as good of procedural generation, randomizer, anything like that we can't just use PCG for, because the tools are already there. We may as well use them. And that was very shortly after the whole tree thing, when I was watching some PCG videos of people just moving splines around, and I was just like, this is like, as a programmer, I love this. I can set up this, I can set up this, I can do this, and then I can be like, artists, have fun. Do your thing.
That's the best part, right? Being able to just build the tool and being like, all right, now run, take it and run.
But yeah, this is basically the end of that. We've put a spline around our regions and told it to run as PCG graphs. Then we go to our this is an actor we have on the level that has a huge volume around the level, and this graph gets ran for things that are not specific to a region. The two things that mainly come off the top of my head at the moment are basically our rifts and our roads. And then, we've generated everything. We've created our render targets. We told everything to update, made our splines, ran our PCG graphs, and we're done. So drop the loading screen. One thing that I do kind of want to showcase is we've been kind of trying to get away from landscape a little bit because of, I don't know if you guys noticed it earlier. It's very hard to get enough geometry from landscape where you really need it. And so you end up with stuff like this, where you don't really have enough vertices to work with. And it is very true. We could actually just fill out more vertices in the landscape and shrink it a little bit more. But this comes with a huge scaling problem. And we are not entirely certain if we'll actually be able to do it. But our original vision for this and hopeful end goal is to have like dozens upon dozens of player accounts. I mean, we're talking huge sprawling maps here, potentially. And, you know, as it grows and grows and grows, you get less and less resolution. So landscape just kind of doesn't work for us totally. And that was another place. I've already mentioned it once when I was talking about the volumes that we put around each region, the dynamic mesh component. We've actually been looking into using. I actually copied some of the code from the crop out sample that you guys have, the little city builder.
Oh, interesting.
And I started to put together a tiny little testing function. Did I already hook that up? No. So what this function does, before I go through it, is we hide our landscape. We don't want to see it anymore for this test. I don't remember why I was just showing that, probably for a good reason. Probably because I'm creating one later. Yep, because I'm creating one later. So basically what this does is we get all of our region clusters. We then feed it a bunch of data. And we, this was the code that I pulled a little bit of from the crop out sample. I basically just took it because I had the same ideology or idea, which was basically in crop out, they make like a cone and it extrudes up out of the water and then it's chopped off and tessellated, I do believe, into a bunch of tiny little islands, which are then merged together. Well, I think I'm actually backwards here. It's cones, then merged together at the bottom by a block, and then chopped off, and then tessellated, maybe, I think.
Mm.
And I tried to apply the same thing here. We actually have a really good working model. I need a little bit more work on it because I have these annoying little inchers. I have annoying inchers. I'm actually just going to move this over here. Don't need it. Oh, right. I forgot about that. Yeah, this will take a second. The doing this in Blueprint, it's a lot of looping, and this stuff is a little bit taxing, so it blocks the thread for a second. But I don't have any visuals here. Like the shaders are all bad and stuff. I'm just gonna wait for the PCG graph to finish its thing really quick. But I felt initially like this was going in a really good way. There we go. I want to kill my fog of war and my indicators. I felt like this was going in a...
do to you?
What was that?
What did the fog of war ever do to you?
Got in the way. But you'll notice, this is basically the identical same thing that the landscape is already doing. The only difference is that the edge right here is a little more pronounced, rigid. Doesn't quite blend into the rock quite as much. And I'll showcase that in a second, but you can actually see that it never, I don't get any of the vertices that kind of, how do I put it? They don't blend over the rocks badly like the landscape does, because I have a lot more geometry to work with here. And if we actually applied our materials to this, which I'm working with our tech artist to do, we get much better visuals here to work with. And you'll notice that this is already almost identical to our landscape. Like if I look at one of these areas here, you will see kind of rigid up here a little bit, but our existing landscape already has that a little bit. And it's no different. The only difference is that doing this, our rocks and this material, the grid material that was using, is not blended to meld into the rocks as well as the landscape does currently. But even on our landscape, if we go, right, I gotta wait for PCG. I need my rocks. That has been our only downside to PCG so far, I will say, is it does take a little bit to generate, but that is also partially our own fault because we have some very unoptimized graphs that need some work to kind of not be so brutal. But like here, you can actually see this very easily. Like if I get close enough, this little seam here, you can see where it's blending into the rocks here. It's basically the same. And if I can actually get the same thing with the procedural mesh component, and I can actually cut every one of those apart into their own meshes eventually, we get the benefit of not having to render all of the regions all the time, which is a huge bonus over landscape because even though it does kind of optimize a little bit for that, it's not nearly as good as what the dynamic mesh components could do. So that's one of our hopes for fixing some of our rift issues. It actually also fixes this issue. Our landscape here kind of does this. But yeah, I'm not really sure what else to go over. So that was kind of my segue to point out that that is basically what I have done to generate a world, put some splines on it, put some PCG components on the regions that they belong to, and I basically hand the rest of it off to Ivor.
Very nice. Thank you so much for walking us through all of that. That was really interesting. Again, I love that we're able to see kind of the process of what you all went through from beginning to end, see the different iterations and stages and how you got to the point that you're at now. It's very helpful to be able to literally see it and visualize what you the hardships that you went through.
Even for me to understand better our game.
Yeah.
Okay, so I'll jump in now from the art perspective of using the PCG, and how Brent said at one point that he was happy to toss the final splines and now fill it up with PCG for artists. And to be honest, this is also something in art we like, because we like to play with stuff, and especially when we are having all the tools at the disposal, because sometimes it's really hard to talk with to explain to programmers what we as an artist would like to have as a tool. So sometimes it's like, but I want to do it this and this, and it doesn't bring, it's not the programming way of how things should work, and it's more of like, but I want pretty pictures, and it's hard to go back and forward to develop those tools. And that's why PCG is really, really handy, because for artists that let's say before using PCG, my understanding of code was I couldn't write any code, but I could understand simple codes and go over blueprints and visual some stuff, but just get into it and make it happen, it wasn't always an easy task, even in how it's called, the prototyping phases or anything. But when I started using PCG, I need maybe few days of training and looking tutorials, and after that I was pretty much ready to start prototyping, working with it and experiment with it and try to see where can I push it and everything, because nodes that PCG used are quite simple, straightforward, and you just go step by step, and it's really hard to miss it and make it wrong. So yeah, overall, when we start using the PCG, we did on our latest project before the dominance, the Red Solstice 2, we were also using the, let's say, partially procedural generated levels. And on that project, we used some, it was the plugin for the Unreal that kind of faked the, how it's called, that was the tool in Unity for prefabs, and with that tool we kind of did what we wanted, but it was really limited, and we didn't have like the best experience, and we still need to do a lot of fixing of it and everything. And so when I heard that we need to do the fully procedural world with the new tool that is, I want to say, experimental but new in Unreal, and it's like I wasn't really confident none of it is going to work, and everything was like yeah, everything sounds like a magic until you try it.
I understand,
but
especially with experimental ahead of it. I can understand.
Yeah. But I was really pleasantly surprised, because pretty much everything worked out of the box, and we started, I think it was 5.2 or 1 version, and that version had some issues with the PCG, but it was corrected fastly, and learning curve was really fast, and also the tutorials, because it's in-engine tool, it has a really big coverage, so you can really go fast over it and iterations. But yeah, when we start doing this, the first iterations weren't that nice, of course, but I will go over some of the graphs, and actually the final unfortunate graphs, because the iterations between, that's something I do not have. Okay, but we can go here and we can open PCG for this region, for example. And the idea of the PCG, and as you can see here, actually each segment, so this is, all of this is here. So for the whole grass on the level, it's really simple logic, just adding few stuff here and there. And then you can easily differentiate each model or each patch or anything you want. So you can have, like we have here, grass, forest, rocks, villages, and another village, because we have different kind of villages that we can plant. Oh, sorry, no, that's just misspelled. This is the shrines. So the cool thing about this, because early on we figured out we can actually use PCG for all of the stuff, like gameplay stuff, for environment stuff and everything. So that was a really good thing, because at the beginning we were thinking, okay, maybe we can use PCG just for the environment and visuals, and all the gameplay stuff should go over the code. But once we just try a few tests with the PCG, everything worked fine, and spawning blueprints and everything was great. And it also give a really nice randomization and stuff. Now, the only thing, as you can see here, we'll go into more depth here, but this craziness going on, it's the only thing with the PCG that you need to make it a little bit not neaty, but because here all of these connections are connections what should remove something or should go in each stage. So for example, if we start first with the rocks, we go with the biggest rocks. Oh, just give me a second. It's a bit laggy because I have opened everything. So like here, I will put it a little bit here. So we first spawn the big rocks, then we spawn the villages, then we spawn all the gameplay elements, and once everything that is spawned, now we start spawning the forest, the grass, and everything. And most of this stuff, that's why it has a little bit messy connections here that should follow the logic, what is first, what is going after what to be spawned. Now, a good thing about, and I'll show that on the forest, what PCG does, and that was actually one thing that I was really intimidating when I was first looking into PCG and start looking into all these crazy tutorials where they are creating this really dense forest with a lot of details, with paths and a crazy amount of stuff going on everywhere. And I was thinking maybe this is, not for what we want, because it is still top-down game. It doesn't have that much of details and stuff. But it turns out it actually works for everything. So it's, like it said, procedural generated content. It's not just for first-person games. So one thing about the forest is, now as you can see here, and that's actually one of the art rules when you do stuff. So you always try to want to go in some kind of a pyramidical shape. So you never want to have like a flat terrain and then forest. And that is, for example, one thing that PCG easily do, because you have, for example, if we go here, let's see if it's grass, sorry, wrong one. Take a while. Let's go filter and let's go here. So just to see, village, yes, forest. Okay, so as you can see here, for the forest, I start to creating the PCG points, which are those little dots here. I a bit randomized them and already use some density filters to, make them less random, because if we go here, you'll see this is our starting point. So we just have a fully grid, completely filled with points. And then with a little bit of removing the density, then randomizing point. So just few little steps and I already get something really interesting I can work with. Now with that, I can go further and choose, let me see if it's here or it's here. Yeah, okay. So now with this, I go further and I selected the only points that are at the start of the forest. So I left like the majority of the forest is just rendered inside, and I get the points where I want to get those transitions over the forest. And I fill up with a different scaling and rotation and, different props if I want, or trees in this segment. So yeah, so with this and just few nodes of logic, I can quickly select each area I want to work with. I can adjust each area I want to work with. And as you can see here, those differences are again just the nodes which where I select, okay, I want to remove the forest from this, and I want to remove forest from the village, I want to remove forest from the road, and all the stuff that needs to be removed. And the rest of it, it's really simple. It's really just few nodes, nothing special about it. And that's the beauty, what I really like about the PCG, because you don't really need to go having like really crazy complex logic and graphs to get something working, as you can see here. So we still already have all the forests and villages and, shrines and stuff like that. So here you can also see this is something implemented into the logic of the village. And yeah, so let me see if it's that. Yeah, so another thing here is, and I actually remove. So when we were creating villages, I went with a different approach here, because the villages had another problem. Because once you start spawning the village, and if the village is in the middle of the forest, I still get that, you know, dense forest is going here, and then just cut out in the middle of the forest there's a village, and we still needed that transition there. So all of that again worked really easily, because all the logic, what I was talking about, the main forest, I just added to the village, around the village. Okay, a bit laggy, sorry about that. But yeah, the logic was the same. And then once the trees were created with the village, those trees were the ones that were cutting into the forest. And with that, you can really easily can get results like, you know, natural feelings of the village and the forest around. Also interesting thing to do, but I need to go here. Yeah. Another advantage of the PCG is that you can spawn points on the mesh itself. So that kind of fixes the problem of having things like mountains, because before we have a mountain and then, you know, it was just a model and the forest was around, and it didn't really feel good, because, you know, you want something more like this and not just, you know, empty mountain and then a model and then the forest. So that's another thing that is really nice with the PCG, and it's just out of the box with really little fuss to set it up. And yeah, and with those things, we're starting to get really nice effects everywhere. Now, there is one thing that we're still also figuring out, and it's really good to mention, because so far all of the stuff is not really connected with the terrain itself. So there are ways that you can spawn foliage over the shaders, terrain shaders, and with that you can control then in the shader where, for example, if I have a grass, I'll spawn a grass. If I have dirt, I won't spawn dirt there. I won't spawn grass there, not dirt, and things like that. So mountains and everything can be controlled over that. But we found there is also a node that is texture data that is actually using textures and creates points from it, and that's our next step to implement and try it out. We have a little bit problems, because at the moment, the way how Brent explained and how the world is created, we actually started from the villages, I mean settlements, and then those settlements are creating splines and everything. And when I start applying the texture node, the texture node just went around it. So we were looking into ways that we took the whole how it's called, the whole projection of the map, a render target from the map, and that render target connects to the shader that it takes out those elements, which are rocks, which are, for example, here we have here, of course, because I have to show it, so it's not, but we should have some frozen lakes, maybe here. And now, see, now we have a frozen lake, and with this node, these are the things that I'm still looking into to remove all of the stuff from it. So with render target, if we get the whole map, and then we can have one texture for the whole map, and then implement that texture with that and remove it. So we're still figuring out if that's going to work. But the idea is, if we do that last thing with the PCG, then really there is nothing you cannot do with PCG and control pretty much everything you desire. And that is really, really exciting to use. But yeah, okay, let me see what else. Okay. So, and that was for the splines itself. So the volume of the spline is controlled like that. And as you can see here, we have the same connections of the areas, and each segment has its own cell. And that's also something that Brent already mentioned, is that with the PCG data, we use different graphs. We can store it and then create visuals for each, I mean, not each here, but different kind of visuals for the same biome. And with that, we can still have a much, much richer world, because now you won't have, for example, here, what we can do is, we can have area with forest, area with, fields, then we can have more rocky area, and that will create even more, believable world where we are aiming for. And with that, I would still mention one thing also Brent was talking about, and that's the riffs, because riffs were really tricky to do from programming, but also from the art perspective, because riffs, we used a lot of iterations here, and in the end, we just choose the easiest and most straightforward one. But at the beginning, we were trying to get those straight line in the middle, and using that as a spline, and then creating the whole rift in PCG as a spline. So it was like, that was the tutorials we were looking at, for example, how to do the road. So you have like the middle part, and then the models around the road, and then some trees and stuff, near the road and everything. So we started with that because that was kind of the most logical way to do it, because it's still kind of like a road, right? But turns out that with that we had even more bigger problems that now with the landscape and stuff, because the cutting, the models didn't work properly, and it just didn't feel right. So in the end, we just use, again, because we already have a spline, and the same spline creates the volume inside, and then that spline also creates like just spawning around the area of the of one cell. And that was really interesting because to develop, because sometimes those ideas that you think they are really logical and just go with it, then you realize no, it's even more complicated than the good solution that you kind of need in the end. Yes, that's the one thing. And I mean, yeah, basically the PCG, it's as it sounds interesting, but it's really simple, and that's something I really want to point out multiple times, because what I would suggest to anyone is to start fiddling with it, because it will give you good results. With this, we already think using this stuff even for grid-based levels. For example, if you have something like a room, or inside of the room, or anything like that, which is more rectangular shapes and it's not this organic, but I already see that PCG can also help there. And it can be really needy for decorating walls, the corners of the room, the middle of the room, pretty much everything can be controlled with it. So it shouldn't be used just for the, organic stuff. And I think the implementation can be, for really different stuff. What I want to show here is, for example, if we turn out, let's turn off the rocks. It's gonna take some time. And now you can see, if you just remove one element, we can still have, that's also a really good thing about the PCG, because if the logic is good, you can play, for example, like I said, if you want to have a different different elements of the same biome, you can practically make one with all of the elements you want. So let's say, imagine that the whole world is one big forest, and then I create one PCG graph with all the logic for the whole continent. And then I can just make duplicates of that and variations where I say, okay, this one, I don't want it to have rocks. I don't want it to have, you know, deeper grass, just smaller grass. And now I'm already giving a bit different environment. I mean, still here is not that much of variety because I just have forest and rocks. But for example, if we go again, let's put rocks. Let's kill forest completely and put the grass. I didn't kill the whole forest.
You can't. You can't kill the forest.
It's too strong. I agree. Now we have to find it where it is. But I guess it's grass. Okay, rocks are going in, and these are just rocks. So I guess it just didn't delete it all. Let me try again. Okay, so yeah, so maybe it's somewhere hidden. No.
I'm just working under the assumption that it is that the forest is too powerful and nothing we can do.
But yeah, we can, if we kill the villages, that will also partially kill the forest. Oh yeah, here there was. Okay, so now that's maybe not the prettiest environment right now, but with few clicks here, I already have a starting point to create more like a tundra part of this environment that is just more rocky, and add more models of rock and grass without the trees. And with that, now I can have, you know, let's say this area will be like this will have more forest, and, you know, it gives really nice variety, like I said. So yeah, overall with this, also with the same pretty much logic, if we go in this region, now this region, which is interesting from this one. So the idea here was that I start using the coverage of points that are, let's say, density 1 to density 0, and it have with the gradient. So I tried to create things that are more dense in the middle of the area and then less dense to the end. While here, the logic here was just the reverse. So I said, okay, this is desert, so most of desert should be bland. I mean empty. You shouldn't have that much foliage. So I created that density go, so 1 is here, 0 is here, and that's just a single, you know, switch into the yeah. So with the small graph, just changing it from here to here or here to here, you just can control it easily, you know, how things gonna control here. And if we go here, let me see if we go everything from 1. Yes. So, for example, if we go here and we go here, and now we have reverse, right? Really easy. And for example, if I want to do again just a variation of that, just with the simple thing, with just few little things changing, you can get really good results really fast. And yeah, I don't know if there is anything else. I think I cover it all. For all of it, I think think,
Amazing.
yeah, that's it. Because, a good thing about the PCG is that you don't need that much things to show. It's those few things. I mean, I can go over the basic nodes, but those all nodes are covered in Unreal tutorials and documentation. So, and all of them are like, I think there are maybe 10, 15 nodes, and with all of that you can. And I'm not even using all of them because I just use some. I won't say all basic, but really simple stuff and really simple logic for that, and it gives really good results.
Just what you need. Yeah.
Yeah, exactly.
Awesome. Well, oh my god, there was so much stuff that we just got to go through. That was awesome. I really felt like we got to learn the full process of what you all went through, and to get an idea of how we got to where we are now with the game at its current place. So thank you so much for walking through that. That was genuinely incredible.
Yeah, thank you for having
All
us.
right. Of course. Well, if you're up for it, we do have some questions for y'all that I'll toss your way that we've been collecting from chat throughout the show here. So I'll just ask them out. If both of you want to answer, feel free. Some of them do have you called out specifically by name, but if the other one wants to hop in, listen, you make the rules here, so answer whatever you want to. So we'll start from the top of the list here and go through. We'll try to get to as many as we can. I don't want to keep you for too long. I've already taken up a lot of time out of your day, but we'll see if we can't get at least most of these. So first one up here is, does Atre Dominance Wars, did you develop the game mostly with blueprints or with C++? And I feel like we saw it was mostly blueprints, but would love your full opinion on that.
That's a kind of hard thing to quantify, because I did actually try to keep a significant amount of the project in Blueprint, mostly because it's early in the project and I like to iterate a lot. And it can be easy in certain places with C++, but it's sometimes easier just like I was doing in the stream here, just unhooking a block and having a bunch of stuff just not run. That's nice. So you may have noticed when I was going through the nodes, I don't know if any of you saw my scroll bar in Writer, but it gets pretty long in the world map landscape stuff. And we do have a significant amount of code for like our inventory system, like our avatars have artifacts and stuff, all that, the whole inventory system is all in C++, that kind of thing, because it's a system. We tend to do systems. Ironward as a whole, we tend to do systems themselves in C++, and we still like the script in Blueprint. We like to do kind of the glue the game, play together in Blueprint, get a feel of the game, and in some cases, like for example, small segue to that, I didn't even cover that, but roads in our game was very fun. I also stalled the project for like 20 seconds at startup because I learned how to create a minimum spanning tree, which in itself wasn't actually that slow, but we actually do multiple minimum spanning trees. I don't know if you can see it so much from the roads, but every cluster has all of its main points connected to each other. And then every cluster is kind of connected to at least one other cluster. And we did this because we didn't exactly want every single node to be running roads everywhere. We didn't want a ton of roads going everywhere because, it creates a very unbelievable world, first of all, and it also kind of feeds into the gameplay aspects because we don't know yet whether or not we want to have like spells that create roads or destroy roads or that kind of thing. We have no idea yet. We're still kind of experimenting with that. And so we had to have a good way to do roads. And I had to do this. I originally actually did it based on all of this stuff for the world map. And I actually moved that into its own manager, which is C++, that I can basically give that manager 2 region points and say, I want a road here. That way, if we have, like, the gameplay itself actually goes through with a minimum spanning tree with each cluster, and then it does another minimum spanning tree of each of all the clusters. So that generates the original roads for the game. And then, if we say decide to make a spell that creates a road, I can simply just tell that manager on the server, hey, I want a road between these 2 regions.
Right.
And I feel like a lot of our gameplay, like pretty much all of our UI is Blueprint, I do believe. Most of our gameplay, like our abilities and stuff, I don't know how much people know, but we actually used the gameplay ability system in Dominant at Atre. I gotta stop calling it by the internal name.
It's okay. I get it.
But most of our abilities are blueprinted. And then, yeah, like I have a ton of C++ code in the generation for the world because Blueprints is wonderful. It really is. It's fantastic to use for quick iteration and such, and for literally blocking out logic. But it is exceptionally slow with certain tasks, especially iterations and such. So,
Understandable.
Put it where it works best and where it will serve you best as a developer.
I feel like that's a good answer. I feel like that is more helpful than just like 50-50.
Depends on the project, but yeah.
Awesome. Next question we've got here for y'all is, how did you find a balance of color that looked stylized but not overdone?
Oh, that's the worst question to ask.
Too bad.
Well, yeah. So before I actually start answering, I will say, well, you just fiddle with the colors until you say, okay, this is good. And in the end, the whole process is around that. I mean, I really went deep into the color theory and everything over the ages, and to be honest, I can still say I really don't understand the whole thing, how it actually work. And it's all, logical, and it's fine, and all these color palettes and everything when you're choosing them, and it's all straightforward until you start having a lot of stuff on the screen, a lot of things going on. And I mean, there are still simple rules, but I can actually show you can then share a screen to just some of the elements, because it's not just the colors that give a certain look. Usually, to get a certain look you want, you have many factors that you need to factor in. But give me a second, it's laggy a bit. The idea of getting the world the way we want it, the first thing is that we used oh man, what's happening now?
Oh no, we broke it.
Yeah.
It's the forest. It's came back for its revenge.
Okay, I don't know what's give me a second. Get back. Oh, you're here. Okay. So
that looked really cool for a second, I'm not gonna lie.
Yeah. So we can go here. So for example, the idea of connecting things together is we started with what I like for, especially for these games, and overall style is the simplified realism. So the realism, but you actually simplify things and you oversize things. Like for example here, if you do little tents, then you do oversized little things, which kind of show that this is stylized, but again, the textures and everything are more realistic. So if you go here, so you have rocks that are quite sculpted, and then a little bit more simplistic things. And when you start connecting those things, this is the first layer you will get somewhat, like you said, that it feels stylized, but it's not overdone, because it's in everything we built that has that rules. So it's not just the colors. For example, and that's actually one thing we didn't talk about, but I'll just mention it, because with all this, the lumen and 9net is also one thing that really works well, because if you look at these trees are actually mega scan trees, and they're having around 50-60,000 polygons each, and we have a lot of them, and everything works great. So what I want to mention is, the trees here, everything is realistic, but with some elements that are not, and that's why it gives you that feeling between stylized and real. And the colors were pushed just a little bit in the same way, so they're still in realism. So you have all the details on them. For example, little rocks, little sand dunes, and some elements around them, but the colors are a bit vibrant and saturated. One thing that really helped for that is the way how we painted the terrain, because this terrain is not painted with the albedo colors, but we are actually using just the grayscale albedo and masks, and we are using the the color graph for coloring that. That's something our tech artist was really happy with that system, how he did it. And with that, we can actually get much more colors from actually here, the whole terrain is just blended with two textures. So everything here, just two tileable textures, and here again, just two tileable textures. But with the variation in colors and stuff with it, you get a feeling that it's much more happening there than actually is. But yeah, so to get something like that, it's not just the colors, it's pretty much the whole thing, and you have to look at it as a whole picture, and trying to nail all these little steps that will lead to the result you want.
Very cool. Awesome. Love that little bit of insight there. Next question here seems to be specifically for you, Bran. As someone digging into a project and trying to tackle concepts I've never done before, how did you find a way to stay motivated and not feel totally overwhelmed? I feel way out of my depth in my current project.
I feel that question. Random tidbit of info. I was originally brought on to Red Solstice 2 as my very first professional project ever. I don't think I did anything even remotely complicated before this, and I got hired on Red Solstice 2, and I spent, I think, a week or 2 weeks, I can't remember, on the profile system. And then I started getting more and more tasks, and it was a very harrowing experience, because I had before that time, I had never worked in professional developer roles at all, so all new, all of it. And I only very recently stepped into a project lead role, which also came with the benefit of doing world generation. I will happily say that this is nothing like the scale of Hello Games and anything like No Man's Sky, but I will say that this project has given me a lot of respect for those kind of games, because learning, you might have caught this, I don't know if you did earlier in the stream, but I had no idea what Voronoi was before any of this. I vaguely knew what Perlin was. I think I'd used it like once or twice before this. I had never worked with any sort of geometry tools, anything like that. That was all brand new to me. And I had barely worked with splines before. Like I said, I was a UI programmer. Everything that I had done up until this point was basically mostly UI work with some basic logic and other general systems. And I feel you. I feel you that it was very daunting, and that it can be a very crushing experience to get a task and you're like, I don't know how to do this. Like,
Yeah.
I like, the worst thing is I don't even know how to start doing this. I don't even know how to research to start doing this. And I will say one thing. If you have colleagues, talk to them, because it helps. For example, great example is actually roads. We started doing the roads for the villages. I didn't know what I was doing. All I knew was I had a bunch of different points, and I needed to randomize the roads between each one of them. And every point needed to have a road. So I start Googling. I'm basically coming up with them empty-handed over and over and over. And eventually I found this tiny little thread of minimum spanning trees. Never heard of it before. Couldn't even tell you what it was before then. Spent a couple of hours researching on what a minimum spanning tree was, and realizing that, funny enough, I actually applied this to a UI thing after this. But basically realizing that it's just giving a system a ton of points and saying, I want to find the minimum amount of connections that I would need to connect all of these points and not have all the extra connections between all of them. And I vaguely got through that part, but then we had all this stuff with having to project them everywhere, having to figure out how we were going to do the bridges, having to figure out more than just data. And I had no idea what I was doing, and Ivor helped me there quite a bit. I do believe Hervoye gave me a few things to reflect on. So if you're ever feeling overwhelmed, honestly, talk to colleagues, because even if they don't understand things, like, I got insight from Ivor. He's an artist. He does not do programming one bit, but his insight into art, his insight into art helped me a ton with figuring out a way that I could do my job better. And quite honestly, I love challenges. So give me something to pick at, and it's just fun for me.
That's awesome.
Yeah, I could just add for the last thing what you said, and I think those kind of tasks are the best tasks, because once you figure them out, these tasks you grow as a developer. Because if you just do the thing you know constantly, you'll just become dull, and you'll be scared and more scared to do new stuff, because you'll be in your comfort zone. And yeah, as it sounds crazy and scary, and but dig in and just do your best to figure it out. And once you do, you'll feel really rewarding.
Don't be afraid to ask people if you can put tasks aside too. That's another big thing. Like, even if you have a lot of stuff going on in your project and there's a ton of things to do, consider asking if you can put your current task aside for a little while and work on something else, because sometimes you're just not in the right mind frame to solve problems. And sometimes it helps to kind of chew on easier things for a little bit, and then all of a sudden, kaboom, you're like, why didn't I think about that before?
Yeah, setting it down, taking a break, coming back to it with fresh perspective, for sure. Awesome. Well, wonderful advice there. I feel motivated, so The next question we've got for y'all here is, how large did you end up making the map overall?
I will leave you, Brent, sorry. But I'll just jump in a little bit because I just talked with Hrvoje and we confirmed it. We can go up to 32 players at the moment. So really big map and it works. It was tested on 12 and it ran smoothly with no issues on multiplayer and everything. I mean, common bugs because we are still in production. That's normal, but it worked smoothly. But yeah, I would kind of leave Brent to explain how actually we do map, because I think we didn't mention that, and I think it's really awesome.
I mean, mostly it's just player size that generates the grid, which I did talk about. But as far as how big a map can get, I don't know the actual dimensions. Off the top of my head, I do believe some of the larger maps hit I want to say 200,000 centimeters. I could also be way off. It may be 2 million. I'm not sure. So I can't
Those
give
are
it
a little different, Brent.
I can't give an honest scale about the literal like centimeter size, but yeah, player wise at least 32 is our current like target, but personally I kind of want to shoot a little bit higher than that because I think we can do it, but 32 is our benchmark right now.
All right, so 32 for now, but we'll see what the future holds, is what I'm hearing. All right, next question is, did foliage cause you any FPS problems whilst building?
Of course it is. As usual it is. Yes. Well, the thing about the foliage here, as I just mentioned before, I mean, we are using really dense geometry there. It's like crazy dense for this kind of a game. So it's like, you know, some of the trees even have over 100,000 polygons and everything. So normally none of that would be working. With nanite, I would say at the moment I would be cautious with it because I wouldn't still say this is a magical tool that fixes all of your issues, but it really helps to load things, and it creates other buffers and things in performance, so it's not, you know, free as usual. Nothing is free, but it enables us to, you know, render, you know, like I don't know how many million polygons there are for the trees and the whole foliage. And the difference with having foliage and not having foliage, it was around maybe 5 to 10 FPS just on foliage. So fully world with having all the foliage on the screen, even on the highest camera, you know, elevations, it was, you know, not that big of a difference with having or not having. Definitely having few foliage, that brings a lot of FPS, but adding to it, it doesn't really add with nanite and everything. But we're still looking into a way to optimize it because yeah, it's still, you know, I'm not happy with how it works. So it's gonna be better.
I do want to add to that we don't need to, but we are currently actually LODing all of our meshes because we do actually have an eventual plan to support non-nanite systems and whatnot, so that if you don't want to use the really new pretty renderers and stuff, you can disable it for slightly better performance if you don't have the hardware to run it. But we are still trying to push the graphics as best we can.
Right. I feel like it always is kind of that balance, because you want to have the super pretty, high fidelity, high render option for the best possible outcome. But yeah, also considering players that just don't have the hardware to be able to run something of that capacity at that point is always kind of a tricky balance to find. So very cool that you all are looking into putting in actual LODs for everything as well. All right, next question here. And I'm going to read it exactly how it was written because it's hilarious. Holy cow. all that fog is a particle system?
And I'll say no. No, it's not. The whole
That's
fog.
actually this is a post process actually.
Yeah, and it works over the C++ is working for your part how is hidden or not, but the visual is just the material on the post-process system. So yeah, probably with the particle, the game would explode.
Not just the game, all of the computers just
Yeah.
across the world. I do love the enthusiasm, though, that they put into it, so appreciate that. Next question here is, how did you decide what version of the engine, I believe, to program for?
We didn't. We just went with the newest one, and we still do.
There you go.
Usually on our older project, the Red Solstice. So the way we did it is we upgraded with each version that it came. It always has some issues. Game broke in some of the versions when we start iterating. We kind of was lucky that we come to 427 just before the end of the production and release. But if not, probably when we would be live, that would be the version we stopped and we shouldn't, or later on moving on newer version would be much more careful and rarer. But in the development, I mean, programmers are better at this than me, but what I understood from what I'm seeing from the practice we have is it's good to update your engine constantly, because it will force you even to do the code and everything good that it goes with the newer versions. And
I will say, right now we're basically upgrading to every new engine version. Once we get closer to release, we'll probably stop that for a little while, and we're probably still going to be updating to every new engine version, but we'll probably be waiting for 0.1 or 0.2 of every version to make sure that it's very stable at that point. But yeah, at the moment, we're just running everything new.
I love that. Going with the flow.
Yeah.
Keeping up to date. Awesome. Next question here is, Ivor mentioned a lore doc. How long had that been available before you began building? And would you recommend that someone start with something like that if their game is going to be heavily narrative?
Okay, so for Atre, one thing that we were, I would say lucky, but this game was built on the 20-year-old game. So there was already some lore about it. And, we expanded it from there, but we already have a good starting point. Now, from art perspective, and what I did, quite a bit of level design, more from layouting and not just the logic and stuff. But lore is really important, and you should have it as soon as possible, especially if you're, like you're saying, having heavily narrative game. But you also have to decide at one point where to stop, because if you go into too much details with lore and everything, you could spend 3 years writing something out, and then when you start building that, you realize, okay, that doesn't work, and because it will go over iterations. But base idea, base stuff and everything, the first vision that you have must be written down and complete, because it will help you out a big time when you start developing, from art, from level design, from narrative, from system wise and everything. Because the biggest issues that you can have is if you change the story in the middle of production and say, okay, let's do something else, and then it's not that easy.
Everything
to
changes.
iterate. Yes.
Yeah, for sure. So you have an outline, but not necessarily a novel.
Yes, yeah. I mean, as much as you can, but in a reasonable amount. It's that sweet spot that you'll get when you try, you try a few times and then you'll get it.
You'll find it. They'll find it. Yeah. I believe. Next question here is, when creating each feature, do you measure and polish for performance or leave that for the end of development?
Yes and no. Performance is, of course, important. We want the game to run at its best on even the lowest hardware that we can possibly manage. So, and one big thing about performance is it doesn't just affect the end user, it affects our development iteration too. So things that are glaring issues, we generally do actually put in the time to early optimize, like even if we decide to toss the entire idea later, because it saves us a ton of time testing and whatnot. That it's nice, but there is also, of course, the point you never should prematurely over optimize. That is always terrible, because you, like, same with the lore bit, you can spend forever trying to get the teeny tiny little microseconds out of your time in your game frame, but it doesn't matter unless it matters. So, you know, if it's something that's bugging your development team, sure, optimize it. If it's not, probably something that can be put off until closer to release, because it's not that big of a deal.
Right.
Yes, it's the same for the art, pretty much. Because you always want to have optimized stuff and, let's say, final stuff for assets, because you don't want to redo the assets over and over and over again and optimize it later. But there are some things you're not sure how they're going to work, and no matter how hard you try through the process, you will end up again going over and optimize. So again, it's, with time you will just get what can live and what you can live and what you need to optimize immediately. And definitely for art, if the graphic cards are burning out and something is killing, no one can test, then yeah, it's a good start to optimize there.
Yeah, I get you.
And immediately, yeah.
Let's see. Next question here is, I'd love to see the folder organization you've adopted, if that's something you're willing to share. Sometimes I can't decide what to put where.
I mean, I can show, but there's nothing special about it. I can just find. Can I take it out like here? No. Okay, let's do this. Yeah, but basically, I would suggest that anyone who starts or doesn't work on many projects, then just find online. You have a really good already examples of how to build your structure folder and naming convention, because that's a good start just to get a good practice of, start naming stuff good, put them into good folders. But here, for example, the way we do stuff is in assets, we have separate folders for materials, separate for meshes, separate for textures. And at the start, this is something, for example, artists really hate, because we would also like to have, our meshes with our, give me my mesh and give me my texture and give me my material. But later on, when we start optimizing, just like we talked about before, it's much easier to do bulk edits and see what you're doing where, and you don't have to filter that much. You have a much better overview of things and stuff. How we do the organization, we have this little folder called import, which is for artist, me included, and we are all adding our stuff here. And then our tech artist, who is really hardcore on keeping order in projects, so you will probably need a dedicated person for that. And he's putting everything where it should be, checking our naming, because artists don't really care about naming, trust me, me included. And we are misspelling stuff. And, I mean, we are following the convention, but the misspells, type failures, something like that, always happen. And those things are really important because later on you can end up with a project that nobody knows where things are.
Mm.
And you should definitely go, periodically, once a month, go over all assets you have and just put them where they are, name them correctly. Because later on, also what becomes a problem, programmers start using assets. And I'm mainly talking about the art asset here. And I think art asset is the biggest chunk of, files and stuff in the projects, and they get messy really fast. And when things start to get used into the blueprints in code and referenced somewhere else, if you start renaming them later, that can also cause a big issues. So it's really good to do that properly. To be honest, we also in the end have problems with with the whole assets and everything. As much as we try to be careful with, so you'll always have a little bit of mess. But if you don't care, then you have a big mess, and that can be a big problem.
Yeah. Mitigating it to smaller messes.
Yeah.
Can you go back to the main content browser and expand a little?
Mm-hmm.
At least programmer-wise, and for the rest of the systems, some of you will actually recognize most of these folders, maps, movies. Basically, from a programming standpoint, what we do is the vast majority of stuff usually either goes inside of user interface, programming, or game data, sorry. The reason for this is because we like to keep we like to very heavily separate game data from actual programming classes, because we kind of messed up that a lot on Red Solstice too. We have a lot of stuff that is data on actors and stuff, and it has caused us a lot of headaches because it forces us to load a lot of things when we don't really want them. So we started separating out all of our data tables, our definitions, data assets, all that kind of stuff into the game data folder. Programming classes that actually use those go into the programming folder. These are your gameplay abilities, your actor classes, your bosses in level 3, that kind of thing. Then, of course, we have a very separate folder specifically for user interface, because we like to keep that very separate from the 3D assets. In fact, if you open up the user interface folder, Ivor.
Mm-hmm. Give me a second.
This actually has its own assets folder, because we keep stuff very separate from the 3D art assets, because the textures and materials that we use in UI are very different, setting wise and such, from like 3D assets. So we also don't like to mix user interface at all with our core programming. So it gets its own special folder that kind of just sits within the rest of our project.
Awesome. I love that. So that keeping systems clean between the different teams, making sure it's easy for everyone to know where to go, and mitigating messes as much as possible, even if they may be slightly unavoidable at times. Fantastic. All right. So we have one last question from chat that I'm going to ask you all. And then the final question of the whole evening is a surprise one that I love to spring on all of my guests. It's very hard and it's evil, and I apologize, but it'll be the last one. So we're almost there. So the last question from chat here is, do you recommend using a revision control when working solo or in small teams? They're very early in their development process, apparently, and would like your advice.
Absolutely.
Agreed. 100%.
The thing is, revision control isn't just like, oh heck, my whole project is corrupted because insert random reason here. I do a lot of things in our other projects and even in Dominance. I will test things. I will go into the project. I'll open it up and I'll be like, I want to do this, this, and this. And I'm going to test all this stuff out. I'll have like this huge like warpath of code just totally strewn around and messed up. And then I'm like, yeah, actually, to be fair, I could have implemented that so much easier. I'm just going to go revert all of this and do it the easy way. So it helps you a ton, because if not, I would have had to go back and maybe put in half of that stuff in the right place. And it really helps you with just your iteration processes. And of course, it's also very good for making sure you don't corrupt your entire project.
Yes, of course.
Yeah. And it's the same thing for art, especially when you're fiddling with hundreds of things and, textures and colors, and you have like 50, 60 different materials you're trying to fiddle about a little bit here, a little bit there, and then you realize, okay, and you save all of that because you need to save, you don't want crashes and everything, and then what now? Now I have to go back because I don't like this, and with this, either I just remove the changes, or even if I accidentally commit stuff with the revisions, I can just go back and say, okay, or someone comes and say, hey, you remember that version 3 months ago, the colors you did there, they were excellent, let's go back there. And without that, getting it exactly like it was, it's not that easy.
Right.
So yeah,
I will say, we use, I do believe, plastic SEM for most of our projects. But when I'm working solo, like if I'm doing like personal projects and I'm trying to write out systems or something and I'm messing around on my own stuff that I don't really want to put into a complicated project, I would personally recommend setting up, GitHub Desktop and Azure DevOps, because it is really easy to throw a simple project into Azure DevOps with. I normally use GitHub Desktop because it feels to me a lot like Plastic SEM. So very easy to set up and run through.
Awesome. Some fantastic recommendations there. All right. It is time for the final question. It is my last evil question that I ask all of my guests, and I'm so sorry that I specifically don't prep you for it, because I want your gut knee-jerk reaction to it. But if you had to take all of your experience working on this project so far and distill it down into one piece of advice that you would like to give other developers, what would that advice be?
If your boss comes to you and asks you to write a Voronoi thing, do not do it in a shader.
Solid advice.
I would say never stop doing games.
Aw. Two vastly different pieces of advice here. We got a real full spectrum of the development journey here in these two answers.
Yo.
Awesome. I love that. All right. Well, with that, that's everything. So thank you both so much for coming on the show today and talking about this incredible project, walking us through the process that you've gone through and the building and development of it thus far. Obviously, there's more to do. So if people are interested in learning more about the game, we have the Steam page pinned in the chats right now. So go check it out on there. You can learn more about the game and wishlist it. Keep an eye out for it. But again, one big last thank you to our wonderful guests, again, for taking the time out of your day to do this and hang out with us and answer questions and stuff.
Thank you for having us.
Of course.
Thank you.
Of course. And for everyone watching, of course, thank you also for being here. The show wouldn't be what it is without you and your interaction and your questions and your feedback. So thank you for being here and hanging out with us and learning and just being part of the whole developer, there we go, community here. If you missed any part of the stream earlier, no worries, because we post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channel. You can also keep up with all the latest news and all of the latest and greatest and cool spotlights, just anything really that you might want to know more about on all of our socials at Unreal Engine. And if you haven't already, you should also go join the Epic developer community, where we have our forums, we have tutorials, we also have our documentation for the engine now there as well. It has just about anything and everything you could ever need in regards to the engine, so go check that out if you haven't already. One last PSA, next week is Unreal Fest Seattle. And I completely understand not everybody can make that. For some people, that's a long trip, or you might just not have been able to get tickets in time, or who knows. So to make up for that, we are going to be streaming our opening session, as well as 3 of the presentation rooms over the entire length of Unreal Fest. So that will be happening next week, Tuesday, Wednesday, and Thursday. So if you have some time and you want to just hang out, see some cool stuff, make sure you check out those streams, which will be available on our YouTube and Twitch channels. So keep an eye out there. And if you are going to Unreal Fest, I will also be there. So please come say hi. It would be lovely to meet you all. Awesome. With that, I think the last thing we'll wrap up with is we'll play that incredible trailer just one last time, and we'll end the stream out on there. So thanks so much, everybody, for coming. And we'll see y'all not next week, because we'll see you next week with a whole bunch of streams, but we'll see you for the next Inside Unreal the following week, in the second week of October. So thanks so much, everybody. Bye.
Bye.
Bye-bye.
Another elder returns. Will you venture bravely into the unknown, exploring an ever-changing world in search of power? Will you bring blessings upon others? Or bring destruction? Expand your dominion over the realms. Master the magic of the 4 worlds. Study ancient script and forge artifacts of untold power. Raise your armies and transform them through arcane knowledge. Crush your enemies and their cities. Unleash the might of your legions upon the world. Annihilate all who oppose you and ascend as the Elder God.